So today we are going to graph quadratics in vertex form. The graph of a quadratic is called a parabola. Okay, so that's the word parabola. And the general form looks a lot like our absolute value general form, y equals a times the quantity of x minus h squared plus k. This is our general form. It's going to be the general form of every equation. What's going to change is this maybe a square root? Would that be a cubed? Might we have it in a fraction form? Like everything is a, x minus h, and plus k. And so for this equation, what is the vertex? What's the vertex here? HK. Same as it was when we were graphing the absolute value functions.
That textbook was not right.
Okay. What did the text? So the nice thing about vertex form is it gives us the vertex. We're going to draw some general pictures of parabolas and identify some of the key features. We're going to look at a parabola that opens up. And a parabola that opens down. They both have this point at the top or bottom called the vertex. That is h comma k. Both parabolas have an axis of symmetry. That is a vertical line that passes through h. So the equation of this line is x equals h. And it's called the axis of symmetry. The same thing goes for the one that opens up. The equation is still x equals h. And it's called the axis of symmetry as well. The only difference for any of the things about these two graphs is that one's opening up and one's opening down. And that's what determines anything that's actually different. Yes?
Wouldn't the vertex be negative h negative k?
It is not. Because the equation is x minus h. That means when h is 3, the equation says x minus 3, which is what we're used to seeing, right? It's the opposite. So the negative's in there because it's already taking account of the opposite. Okay, we have this point. Would you call this point here a maximum or a minimum? Yeah, this is a maximum, the highest point. The maximum is actually k. And what would you call this one? The minimum is k. So our domain for both graphs is all real numbers. The range for the blue graph is everything is greater than k, greater than or equal to k. And it's always going to be or equal to because the vertex is a part of the graph. And then for the purple graph, it's less than k, less than or equal to k, because all the points are below it. All right, we're going to graph y equals 2/3 times x plus 3 squared minus 1. What is my vertex? -3, -1. Remember, it's always opposite of what's in the parentheses because that's what makes the inside 0. That's what's going to make it a minimum if it opens up, because the smallest those parentheses can be is when x is equal, or that quantity is equal to 0. That's the smallest that can be. So then the minimum is when that is its smallest. So it's negative 3, negative 1. Okay, you're going to find if you don't flip that sign, your graph is going to look really weird. And you're going to try to use the symmetry to graph it, but the points are going to be really big because you're actually really far away from the vertex. So my vertex is negative 3, negative 1. I'm going to put that in the center of my table, negative 3. And I'm going to graph the point on my graph, negative 3, negative 1. Right here. Now I want to make a little number line with my table. I want to pick some numbers that are smaller, and I want to pick some numbers that are smaller and some numbers that are bigger. I can actually pick any numbers I want. My denominator is 3. It might be a good idea to do multiples of 3, and I wouldn't have to deal with so many fractions. But for the sake of this, the point of me putting the fractions in here was to practice the fractions, right? So we are going to pick two numbers bigger than negative 3, which are what? What are the next two numbers? Negative 2 and negative 1. And then the next two numbers after negative 3? Negative 4 and negative 5. So we're going to create a little number line in our table of 5 numbers, and the vertex is going to be in the middle. Okay? And I know the y value is negative 1. Okay, so I already have that. And we know that we have symmetry because the graph has an axis of symmetry. So what that means is I don't actually have to plug in all 4 numbers. I can use the fact that this graph is symmetrical around this line. And if I have points that are the same distance from the axis of symmetry, they're going to have the same y value. That means negative 2 is going to have the same y value as negative 4. And negative 1 will have the same y value as negative 5. So I only have to plug in 2 of the 4 numbers. Okay, and we're going to do that. So we're going to plug in x equals negative 1. 2/3 times negative 1 plus 3 squared minus 1. Now this is where people make mistakes. This is order of operations stuff. We have to do what's inside the parentheses first. And we're not trying to FOIL anything out. We just need to do what's inside. Negative 1 plus 3 is what? 2. So I get 2/3 times 2 squared minus 1. And after parentheses comes the exponents. So I have to do 2 squared before I can multiply it by the 2/3. So that's 2/3 times 4 minus 1. It's not super complicated evaluating, right? We're just adding and subtracting, raising it to the second power, multiplying and subtracting. It's not crazy stuff. Put a 1 underneath that 4, and we get 8/3 minus 1. Now we could go 2 directions. We could go mixed numbers and make that 8/3. 3 goes into 8 twice with 2 left over, 2 and 2/3. Sometimes that's a faster way to do it because now I'm just I have 2 and 2/3. I'm taking away 1 whole. Now I have 1 and 2/3, right? My other option is to go common denominator. So that's 8/3 minus 1 over 1. I'm going to times by 3 over 3 to make my denominator both 3. So 8/3 minus 3/3, which is 5/3. And when I make that into a mixed number, 3 goes into 5 once with 2 left over, 1 and 2/3. There's not a whole lot of fractions in your homework tonight, but there are a few. We have to be able to work with them. So that means when I plug in -1, I get 1 and 2/3. So what number also has that y value, 1 and 2/3? The -5. Right? We are 2 away from the vertex at -1. The -5 is also 2 away from the vertex. So it is going to have the same y value because of the symmetry. And then we're going to plug in -2. Two-thirds times -2 plus 3 squared. Parentheses first. Two-thirds times 1 squared minus 1. Two-thirds times 1 minus 1. It's kind of a redundant step, but you can write it or not if you want. And 2/3 minus 1 is -1/3. Again, if you wanted to get a common denominator, 1 is 3 over 3. You still get -1/3. So in my table, -2 is -1/3, and so is the -4 because it is also only 1 away from the vertex. Now that I have those points, I already have -3, -1 on my graph. Now I'm going to graph -1, 1 and 2/3. So that's about here. 2/3 is more than half. You're just estimating. It doesn't have to be perfect. Then I have -2 and -1/3. Then we have -4 and -1/3. And 5 and 1 2/3. See the symmetry here? These should be the same y values because they're the same distance from the axis of symmetry. And now we connect it in a U shape. It's not a V. I don't want to see V's on the homework. There's a curve. Questions? What is my domain? X is all real numbers.
Can you re-explain what to do with the 1 2/3 on the graph?
Yeah, so I'm here, -1. I go up 1, and I'm estimating 2/3, right? So I'm going 2/3 is more than half, so I'm going a little bit more than half. I'm not looking for total, accuracy. It's almost impossible to get really good accuracy on a small little graph like this. So it's okay to just be, halfway. 2/3 is more than halfway, right? And then for -1/3, it's less than halfway down. My point maybe looks a little bit at half. It's really hard to do the difference between 1/3 and 1/2 on a small little graph like this. So it's okay. And that would be one of the benefits of using multiples of 3 in our table. If we used 0 and 3, and then -6 and -9, we would get whole numbers for these values. And then we wouldn't have to worry about that fraction. Okay. So what is my range? The entire graph is greater than or equal to the -1. It's going to take it with. It already joined them together. So here we have it. Y equals negative x minus 4 squared plus 3. When it's in this form, We have the vertex. So what is our vertex? Positive 4, positive 3. Okay, always opposite sign. It's positive 4, positive 3. Put it on there, and I'm going to draw my axis of symmetry. And we're going to make our table. The vertex 4, 3 is going to go in the middle. What numbers am I going to choose? 3, 2, 5, 6. I don't have to get fancy with the numbers I'm choosing. Just pick 2 numbers smaller, 2 numbers bigger. Okay. Now we'll just plug it in. Negative 2 minus 4 squared plus 3. So this is plugging in x equals 2. I'm going to give you a second to evaluate that. Okay, so we should, inside 2 minus 4 is negative 2 squared. So negative 2 squared plus 3. Now, people have the tendency to see that minus minus with the parentheses like when you're just subtracting, and they want to make that a positive, but you can't. Because this negative 2 has the exponent on it, and the exponent has to come before you can multiply by the negative. So you have to do the negative 2 squared to get what? 4. So we have negative 4 plus 3, negative 1. Is that what you got? And what number does that also correspond with? Right, the 6. Okay, because these are both 2 away from the vertex. Now plug in x equals 3. Okay, so inside the parentheses we do first, so 3 minus 4 is negative 1. So, and then the exponent has to come next, so negative 1 squared is 1. And then I bring the negative down. Negative 1 plus 3 is 2. So we have 2 for the 3 and 2 for the 5. So we're going to plot those. Positive 2, negative 1. Three, 2. And then the symmetry. I don't even have to think that hard about where I want to put this point because it's 1, and I'm just going to go 1 on the other side of the axis of symmetry here. And then this point here is 2 away, so I'm going to go 2 away here. That gives me the other point, 6, negative 1. And then connect it with a curve, not a V. The equation for the axis of symmetry is x equals 4 on this one. Right, it's vertical, so it's always x equals, and it's passing through the x value of the vertex, which is 4. So that's the equation of the axis of symmetry. My domain is x such that x is contained in the set of all real numbers. And my range is what? Yes, y is less than or equal to 3. Okay, my entire graph is below that 3. 3 is a part of it, so it's a less than or equal to. Okay. So we're slowly filling in this table this week. We're going to start with the vertex form. On Wednesday, we'll do the standard form. Thursday, we'll do intercept form. And then Friday, we'll talk about maximums and minimums and some word problems. Parabolas are everywhere. Do you watch sports? Do you play a sport? The ball travels in the path of a parabola. Kick a soccer ball, it's a parabola. Goes up in an arch, it reaches its maximum height, and then it starts coming down. Volleyball, serves, sets, passes, all parabolas. Throwing a football, right? If you watch Monday Night Football, they like to trace the football down the field and tell you how far it's traveling in the air. That is a parabola. You see it across the screen. Hit a golf ball, same thing. They like to trace the ball on the screen. It's all parabolas. Okay, parabolas are everywhere. They're in every sport because that is the natural path of an object in motion. Okay, so it's not like this is something that doesn't exist. The path of a bullet in a video game travels in a parabola. It doesn't travel straight. So it arches up and comes down. Okay. Less things travel in a up parabola. Most of them are upside down parabolas, like negative, because they have a maximum height. But vertex form, the nice thing about vertex form is it gives us what information when we look at it? The vertex. Vertex form is called vertex form because it gives us the vertex. We're not trying to be tricky around here. That vertex is h comma k. The axis of symmetry, we'll use the abbreviation AOS, is the vertical line that goes through the vertex, and it has an x equals h equation because vertical lines have an x equal equation, and they all have that value h, all the points on that line. Okay, so the symmetry around that is how we get to do half the work to make the table. The y-intercept we get by plugging in 0. You don't have to have a y-intercept on every graph. You might notice the two graphs that we did were over 4 and 3 from the axis, or the x-axis and the y-axis. So sometimes the y-intercept is really big and it doesn't really fit on your graph. And that's okay. It doesn't have to always have a y-intercept on the graph. The roots, the zeros, the x-intercepts. These are where the graph crosses the x-axis. When we do intercept form, they will be given to us. Vertex form, we have to solve the equation. And we're going to do that in chapter 3. But you can look at the graph and identify where it crosses. Those are your x-intercepts, roots, zeros, solutions, all 4 names for the same points on the graph. The graph opens up if a is greater than 0. If it's positive. It opens down when a is less than 0. Or it's negative. And our strategy to graph is to make a table with 2 numbers less than and 2 numbers greater than the x value of the vertex, h. So we're just going to make a table after we have that vertex in the middle and plug in the values.